Welcome to Maclaurin multiple choice questions series, and in this video we are going to discuss MCQs about differentiation. Question 1 is d by dx of sine of x square is equal to, and the options are option A 2 sine x cos x, option B cos of x square, option C 2x cos of x square, option D 2x sine of x square, and the correct option is. But before correct option, let's explain it. Here we find the derivative of sine of x square. The derivative of sine of x square is cos of x square into derivative of x square, which is cos of x square into 2x. It can be written as 2x cos of x square. So the correct option is option C. Question number 2. D by dx of 2a cube is equal to, and the options are option A 6a square, option B 2a cube log of a, option C a cube log of a, option D 0. And what's the correct option? But before that, let's explain it. The derivative of 2a cube with respect to x. Here a is constant, 2 is constant, so a cube is also constant, and the derivative of constant is 0. So the correct option is option D. Question number 3. The function f of x is equal to ax square plus bx plus c has relative maxima if option A greater than 0, option B a less than 0, option C a is equal to 0, option D all of these. What's the correct option? But before that, let's explain it. We apply the second derivative test to check the relative maxima of this function. The function is ax square plus bx plus c. Its first derivative is 2ax plus b. Its second derivative is only 2a. Now, for the function to have a relative maxima according to second derivative test, the second derivative must be negative, that is less than 0. But here f double dash x is 2a, as 2 is greater than 0, so a must be less than 0 to have the second derivative negative. So the correct option is option B. Question 4. D by dx of sine hyperbolic x is equal to, and the options are, but what is the correct option? But before that, let's explain it. The derivative of sine hyperbolic x is cos hyperbolic x, and by definition we know that cos hyperbolic x is equal to e of x plus e of minus x over 2. So the correct option is option A. Question 5. The derivative of f of g of x is equal to, and the options are option A f dash g of x, option B f of g dash x, option C f of g of x into g dash x, option D f dash g of x into g dash x. The correct option. But before that, let's explain it. This is the general definition of the chain rule. The f of g of x whole derivative is equal to f dash x. First we take the derivative of outer function and then the derivative of inner function. So the correct option is option D. Question number 6. D by dx of square root of x is equal to, at x is equal to 2, and the options are option A 1 over 2 into square root of x, option B 1 over 2 into square root of a, option C 1 over square root of 8, option D 1 over square root of 2. What's the correct option? Let's explain. The derivative of square root of x is equal to, we apply the power rule 1 by 2 x raised to power 1 by 2 minus 1, and after taking LCM it becomes x raised to power 1 by 2 into x raised to power minus 1 by 2, and it can be written as 1 over 2 into square root of x, but we are to find the derivative at x is equal to 2. So in this derivative, replace x by 2. Now there is no such option, so we write 2 as a square root of 4. So the derivative can be written as square root of 4 into square root of 2, and it becomes 1 over square root of 8. So the correct option is option C. Question number 7. Derivative of e of x plus h is equal to, and the options are option A e of x plus h, option B e of x plus h over log of h, option C e of x plus h over log of x, option D e of x plus h into log of x. What's the correct option? Let's explain. The derivative of exponential of f of x is equal to exponential of f of x into f dash x. So we apply this formula to dv by dx of x plus h, and it becomes e of x plus h into derivative of x plus h. So it becomes x plus h into 1 plus 0, and it becomes e of x plus h. So the correct option is option A. Question number 8. If f of x plus h is equal to a of x plus h, then f dash x equals. Options are option A of x plus h into log of x plus h, option B a of x into log of a, option C a of x plus h into log of a, option D a of x plus h into log of h. What's the correct option? Let's explain. The function we are given is f of x plus h is equal to a of x plus h, but we need f dash x. For this we have to find f of x, so we replace in the given function x plus h by x, so it becomes f of x is equal to a of x. The x plus h has been replaced by x on both sides, and the derivative of a of x is equal to a of x into log of a by definition. So the correct option is option B. Question 9. The derivative of e of x plus e of minus x is equal to. The options are option A cos hyperbolic x, option B 2 sin hyperbolic x, option C sin hyperbolic x, option D 2 cos hyperbolic x. What's the correct option? Let's explain. The derivative of e of x plus e of minus x can be written as e of x plus e of minus x into derivative of minus x. So it becomes e of x plus e of minus x into minus 1, and it can be written as e of x minus e of minus x. We know that by the definition of sine hyperbolic x or hyperbolic sine x, it is equal to e of x minus e of minus x over 2, and it can be written as 2 sine hyperbolic x is equal to e of x minus e of minus x. So e of x minus e of minus x is equal to 2 sine hyperbolic x. So the correct option is option B. Question number 10. D by dx of 1 over h of x is equal to, and the options are, but what's the correct option? Let's explain. The derivative of 1 over h of x, it can be written as derivative of h of x raised to power minus 1. Apply the power rule. Minus 1 into h of x raised to power minus 1 into derivative of h of x. So it becomes minus 1 into h of x raised to power minus 2 into h dash x, and eventually it becomes minus h dash x over h of x whole square. So the correct option is option C. Question number 11. If f of x is equal to 1 over x minus 2, then f dash 2 is equal to. The options are, but what is the correct option? Let's explain. The given function is f of x is equal to 1 over x minus 2. It can be written as f of x is equal to x minus 2 raised to power minus 1. Apply the power rule and take its derivative, and it becomes minus 1 into x minus 2 raised to power minus 2 into derivative of x minus 2. So it becomes minus 1 over x minus 2 whole square into 1 minus 1 over x minus 2 whole square. But we find its derivative at x is equal to 2. So the derivative is 1 over 2 minus 2 whole square. It becomes minus 1 over 0 square minus 1 over 0, and which is undefined. So the correct option is option D. Question number 12. If y is equal to sine of square root of x, then dy by dx is equal to, and the options are, what is the correct option? Let's explain it. The derivative of sine of square root of x is cos of square root of x into derivative of square root of x. We apply the power rule on square root of x, and we get 1 by 2 into x raised to power 1 by 2 minus 1, and it becomes 1 by 2 x raised to power minus 1 by 2, which becomes cos of square root of x into 1 over 2 into square root of x. So the correct option is option D. Question number 13. If sine of x is equal to exponential of y, then dy by dx is equal to. And the options are, but what is the correct option? Let's explain. The given equation is a sine of x is equal to e of y. By definition, we can write y is equal to log of sine of x. Now we take the derivative of log of sine of x. So its derivative is 1 over sine of x into the derivative of sine of x. 1 over sine of x, and the derivative of sine of x is cos of x. Cos over sine is equal to cotangent x. So the correct option is option A. Question number 14. F of x is equal to sine x is decreasing in the interval from the domain minus pi to pi, and the options are, let's check out which one of these is the correct option. By definition, we know that if x1 and x2 are points of an open interval AB with x1 less than x2, and if f of x1 is greater than f of x2, then function is decreasing. Now let's apply this logic to the first option. Here minus pi to minus pi by 2 belongs to the interval minus pi to pi. Call it as AB, and this is x1, x2. x1 is equal to minus pi, x2 is equal to minus pi by 2. Now we find out the values of the functions at minus pi and minus pi by 2. F of x1 will be equal to f of minus pi, and that will be equal to sine of minus pi, which is 0. F of x2, which is x2 is minus pi by 2, sine of minus pi by 2, and that is equal to minus 1. Now minus 1 is less than 0, or I should say 0 is greater than minus 1. That is f of x1 is greater than f of x2. Therefore, function is decreasing in the interval minus pi to minus pi by 2. Likewise, we can check all other intervals, and we will find that option A is the correct option. Question number 15. The instantaneous rate of change of y with respect to x is given by, and the options are, but what is the correct option? Let's explain. The rate of change of y with respect to x can be written as delta y over delta x. Now we are talking about the instantaneous rate. So we take its limit as delta x approaches 0. And we know that we can write this expression as dy by dx. So the correct option is option D. The question number 16 is, if f dash c is equal to 0 and f double dash c is less than 0, that is negative, then f of x has at x is equal to c. The options are maxima, minima, inflection point, saddle point. What is the correct option? Let's explain it. According to second derivative test, if a function has a second derivative to be less than 0 at a certain point x is equal to c, so it has relative maxima at that point. So the correct option is option A. Question number 17. If y is equal to cos of ax plus b, then y2, that is a second derivative, is, and the options are. But what is the correct option? Let's explain. Here, y is equal to cos of ax plus b. The derivative, first derivative y1 of cos of ax plus b is minus sine of ax plus b into the derivative of inner function ax plus b. So it becomes minus sine of ax plus b into a. Now the second derivative is, we write minus a and take derivative of sine of ax plus b. The derivative of sine of ax plus b is cos of ax plus b into the derivative of ax plus b. The derivative of ax plus b is a, so it becomes minus a square cos of ax plus b, and cos of ax plus b is equal to y. So the correct option is minus a square y. The correct option is D. Question number 18. 1 over x into d by dx of sine of x square is equal to. The options are, but what is the correct option? Let's explain. Here, given expression is 1 over x into d by dx of sine of x square. The derivative of sine of x square is equal to cos of x square into derivative of x square. We write it as 1 over x into cos of x square into 2x. Cancel x by x with x, and we are left with 2 cos of x square. So the correct option is option D. Question number 19. D by dx of 1 over sine x. And the options are, but what is the correct option? Let's explain. D by dx of 1 over sine x, and we know that 1 over sine x is equal to cosecant x. The derivative of cosecant x is minus cosecant x cotangent x. So the correct option is option D. Question 20. D by dx of cos square x minus sin square x is equal to. And the options are, but what is the correct option? Let's explain. We know that cos square x minus sin square x is equal to cos of 2x. So we only find the derivative of cos of 2x, and the derivative of cos of 2x is equal to minus sine of 2x into derivative of 2x, which is sine of 2x into 2, and it can be written as minus 2 sine of 2x. So the correct option is option C. Question 21. D by dx of secant inverse x plus cosecant inverse x is equal to. And the options are, what is the correct option? Let's explain it. We know that cosecant inverse x is equal to pi by 2 minus secant inverse x. It is a well-known fact. We can write it as cosecant inverse x plus secant inverse x is equal to pi by 2. So now we only find the derivative of pi by 2. As pi by 2 is a constant, so its derivative will be 0. So the correct option is option A. Question number 22. Square root of 1 minus x square into d by dx of sine inverse x minus cos inverse x is equal to. The options are, but what is the correct option? Let us explain it. The given expression is square root of 1 minus x square into d by dx of sine inverse x minus cos inverse x. We write the derivatives of sine inverse x and cos inverse x as 1 over 1 minus x square minus 1 over 1 minus x square. The derivative of sine inverse x is 1 over square root of 1 minus x square, and the derivative of cos inverse x is minus 1 over square root of 1 minus x square. Now this expression can be written as these two terms will be added and we get 2 over square root of 1 minus x square. Square root of 1 minus x square will be cancelled with the other square root of 1 minus x square, and we get 2. So the correct option is option B. Ding, ding, ding. Question 24. If f of x is equal to 1 minus x whole square into sine of x, then what is f dash 0? The options are, but what is the correct option? Let's find out. We take the derivative of the given function f dash x and apply the product rule on right hand side. Sine of x into derivative of 1 minus x whole square plus 1 minus x whole square into derivative of sine of x. It becomes sine of x, apply the power rule, 2 into 1 minus x, 2 minus 1 into derivative of 1 minus x, and it becomes cos of x. It becomes 2 sine of x into 1 minus x into minus 1 plus 1 minus x whole square into cos of x. Take 1 minus x common and we get 1 minus x whole square into minus 2 sine of x plus 1 minus x into cos of x. Now we replace x by 0 and f dash 0 will be equal to 1 minus 0 whole square minus 2 sine of 0 plus 1 minus 0 into cos of 0, and cos of 0 is 1, 1 square sine of 0 0, oh, and it becomes 0 plus 1, and the answer is 1. So the correct option is option B. Question number 25. The derivative of sine cube x with respect to cos square x is, and the options are, and the correct option. But before that, let's explain it. We apply the chain rule to evaluate this derivative. Call sine cube x as y and cos square x as u. So we find dy by du. Dy by dx, the derivative of sine cube x will be 3 sine square x into the derivative of sine x cos x, and the derivative of cos square x will be 2 cos x into the derivative of cos x minus sine x. It can be written as minus 2 cos x sin x. Now we apply chain rule and find dy by du. It can be written as dy by dx into dx by du. dy by dx is 3 sine square x into cos x, and we take reciprocal of du by dx and write it as minus 1 over 2 cos x sin x. Cos x will cancel each other. 1 of sin x is also cancelled, and we are left with minus 3 by 2 sine of x. So the correct option is option B. Question 26. The point of inflection lies on a curve where, and the options are, let's check out which one is the correct option. Let's explain it. We draw the sine wave as, here we see that x is equal to 0. At x is equal to 0, the tangent line cuts the graph of the sine function. And we know that x is equal to 0 is the point of inflection of the sine curve. Therefore, the tangents cut the curve at points of inflection. Therefore, the correct option is option C. Question number 27. The point of inflection for the curve f of x is equal to sine x in the interval minus pi by 2 to pi by 2 is, and the options are, let's check out the correct option. Let's first explain it. For point of inflections, the second derivative must be equal to 0. Uh, Here f of x is equal to sine of x, f dash x is equal to cos of x, and f double dash x is equal to minus sine of x. Now we put the double derivative is equal to 0 to assess the points of inflection, and it gives x is equal to 0 plus minus pi plus minus 2 pi and so on, but only 0 belong to our interval minus pi by 2 to pi by 2. Therefore, x is equal to 0 is our point of inflection, which is the option A. Question number 28. The slope of tangent line at any point of velocity time graph is, and the options are. And the correct option is, let's find out. Draw a certain velocity time graph. This is time, this is velocity time graph. Take tangent line at any point of this graph, and we know that the slope of tangent line gives the first derivative of the variables involved in the graph. Here v and t are variables, so the tangent line will give dv by dt, and we know that acceleration is equal to dv by dt. So correct option is option D, acceleration. Question number 29. The point of inflection of a curve y is equal to f of x exists if, and the options are, uh, let's check out the correct option. By definition, we know that the point of inflection exists, or it is possible, if f double dash x is equal to 0 at certain points of any curve. So the correct option is the option B. Question number 30. The Maclaurin series of E of x is, and the options are, let's check out which one is the correct option. We know that the Maclaurin series expansion of E of x is equal to 1 plus x square over 2 factorial plus x cube over 3 factorial and so on. Let's put it in summation form. And it will be x raised to power k over k factorial, where k is from 0 to n. So the correct option is option A. Question number 31. The minimum value point of this function is, and the options are, let's find out the correct option. Here f of x is equal to x square plus 2x plus minus 3. First derivative is 2x plus 2. Second derivative is only 2. Put f dash x is equal to 0. It implies 2x plus 2 is equal to 0. X is equal to minus 1. And at x is equal to minus 1, the double derivative remains 2, which is greater than 0. Since double derivative is positive, therefore x is equal to minus 1 is point of minimum value. Now we find the minimum value. Put x in given function, x is equal to minus 1 in given function, minus 1 whole square plus 2 into minus 1 minus 3, 1 minus 2 minus 3 minus 4. So minus 1 minus 4 is the correct option, which is option D. Question 32. The series that represents a function as infinite sum of terms calculated from the values of its derivatives at a single point is called, and the options are, let's check out which one is the correct option, and the correct option is Taylor series, as it is the definition of Taylor series. So the correct option is option C. Question number 33. If f of x is equal to this expression, then f dash 1 is equal to, and the options are, let's check out which one is the correct option. Here f of x is equal to x raised to power 100 plus x raised to power 99 up to so on x plus 1. F dash x will be equal to 100 x raised to power 99 after applying the power rule, 99 x raised to power 98, and so on. So f dash 1 will be equal to 100 into 1 raised to power 99. Just replace x with 1. And we are left with f dash 1 is equal to 100 plus 99 plus 1. And this is an arithmetic series. Its sum is n into n plus 1 by 2. N is last term minus first term, or first term minus last term plus 1. So n will be 100. Just put the value of n and simplify and get a 50-50. So A is the correct option. Question number 34. D by dx of cos hyperbolic x is equal to, and the options are, let's check out which one is the correct option. We know that the derivative of cos hyperbolic x or hyperbolic cos x is sine hyperbolic x, which is equal to e of x minus e of minus x over 2. Now, divide the numerator and denominator by e of x. So we get this expression, and e of x will cancel each other. 1 minus this e of x will become e of x minus x over 2 into e of minus x. 1 minus minus 2x, 2 into e of minus x. So the correct option is option B. Question number 35. D by dx of log of x plus square root of x square minus a square is equal to, and the options are, let's find out the correct option. We know that log of f of x, the derivative of log of f of x is equal to 1 over f of x into f dash x. So the derivative of log of x plus square root of x square minus a square will be equal to 1 over f of x, that is x plus x square minus a square, into derivative of this function, which will be 1 plus 1 by 2 x square minus a square minus 1 by 2 into 2x. Now we simplify it and get x plus square root of x square minus a square into 1 plus, cancel 2 with 2, x over x square minus a square. After taking the LCM, we get 1 over x plus x square minus a square into x square minus a square square root plus x over x square minus a square square root. These terms will cancel out each other, and we are left with 1 over x square minus a square. So the option A is the correct option. Question number 36. Slope of the tangent line to the circle x square plus y square is equal to 9 at 2 minus 3 is, the options are, let's find out which one is the correct option. We know that the first derivative dy by dx gives the slope of tangent line at a certain point. So all we need to do is to find dy by dx. Given circle is x square plus y square is equal to 9. Its derivative will be 2x plus 2y dy by dx is equal to 0. Dy by dx will be equal to minus 2x over 2y, which will become minus x over y. Now the slope m of tangent line is equal to dy by dx, so it will be minus x over y, and we are to find the slope at 2 minus 3, so we replace xy with their respective values. So the slope is 2 over 3. Therefore, B is the correct option. Question number 37. Equation of tangent line to the asteroid at point 11 is, the options are, let's find out which one is the correct option. We know that equation of tangent line at point x1, y1 having slope m is y minus y1 is equal to m into x minus x1. We have the point x1, y1 as 1, 1. We only need the slope of the line. We know that the first derivative gives the slope of tangent line. So we find the derivative of given asteroid x raised to power 2 by 3, y raised to power 2 by 3. We take its derivative. 2 by 3 x raised to power minus 1 by 3 plus 2 by 3 y raised to power minus 1 by 3 into dy by dx. So dy by dx is equal to minus x raised to power minus 1 by 3 over y raised to power minus 1 by 3. So dy by dx can be written as minus y raised to power 1 by 3 over x raised to power 1 by 3. Therefore, slope of tangent line at point 1, 1 is, we replace y and x by 1. We have 1 raised to power 1 by 3, 1 raised to power 1 by 3, and slope is minus 1. Therefore, equation of tangent line is y minus y1, 1, m minus 1 into x minus x1, 1. Y minus 1 is equal to minus x plus 1. It becomes x plus y is equal to 2. Therefore, B is the correct option. Question number 38. If y is equal to this and y of 0 is equal to 1, y1 of 0 is equal to 1, find the value of P. The options are, let's check out which one is the correct option. Here, y is equal to tan P tan inverse x. It gives tan inverse y is equal to P tan inverse x. After taking derivative, we get 1 plus x square into y1 is equal to P into 1 plus y square. Here dy by dx has been written as y1. Now, according to given conditions, at x is equal to 0, value of y is 1, and at x is equal to 0, value of y1 is also 1. So we replace these values in the above equation and we get, and it gives p is equal to 1 by 2. Therefore, correct option is option C. Question number 39. d by dx of cos hyperbolic inverse secant x is equal to, and the options are, let's check out which one is the correct option. We know that the derivative of cos hyperbolic inverse x is equal to 1 over square root of x square minus 1. Therefore, the derivative of cos hyperbolic inverse secant x will be equal to 1 over secant square x minus 1 into derivative of secant x. We know that secant square x minus 1 is tan square x according to trigonometric identity, and the derivative of secant x is secant x tangent x. So after taking a square root, we are left with tan x in denominator into secant x tangent x. Cancel out tangent x and the answer is secant x. Therefore, the correct option is C. Question number 40. If x is equal to 2 cos theta, y is equal to 2 sin theta, then dy by dx at 4, 3 is, and the options are, let's see which one is the correct option. Here we are given the parametric equations of circle. X is equal to 2 cos theta, y is equal to 2 sin theta. We square and add and get x square plus 4 square is equal to 4. We take derivative of this equation. D2x plus 2y dy by dx is equal to 0. It gives dy by dx is equal to minus x over y. So at 4, 3, the derivative is minus 4 over 3. Just replace the values and x and y. So the correct option is option D. Question number 41. For the function f of x is equal to x mod, the point 0, 0 is, and the options are, let's check out which one is the correct option. We know that a stationary point is the one at which the derivative of a function is 0, and at the critical point the derivative may be 0 or the derivative doesn't exist. Let's check out the differentiability of this function at 0, 0. We know that by definition f dash a is equal to this. We replace a by 0 and replace f of x by x mod, and we get f dash 0 is equal to limit x approaches 0 x mod over x, and it becomes f dash 0 is equal to limit x approaches 0 plus minus x over x. So the derivative of the function at x is equal to 0 is plus minus 1. So the limit is not unique. So the derivative doesn't exist. It means that there is no tangent line at x is equal to 0. So the point is critical point. So the option B is the correct option. Question number 42. If x, y are in common domain of functions f and g, and f of x is equal to y and g of y is equal to x, then the options are, let's check out which one is the correct option. We are given y is equal to f of x and g of y is equal to x. We replace the value of y in the function g. It becomes g of f of x is equal to 1. Now we take the derivative of both sides, and we apply the chain rule differentiation, and it becomes g dash f of x into f dash x is equal to 1. Now replace f of x by y. It becomes g dash y into f dash x is equal to 1. So C is the correct option. Question number 43. The derivative of t square plus 1 raised to power 5 with respect to t square is, and the options are, let's see which one is the correct option. We use chain rule to evaluate this derivative. Place y is equal to t square plus 1 raised to power 5 and u is equal to t square. From y find dy by dt, which will be 5 t square plus 1 raised to power 5 minus 1 into derivative of t square plus 1, which will be 2t, and we get 10t into t square plus 1 raised to power 4. Du by dt will be 2t. Now we apply chain rule. Dy by du will be equal to dy by dt into dt by dx. Dy by dt 10t into t square plus 1 raised to power 4, and we take reciprocal of du by dt, that is 1 over 2t, and it becomes a 5 into t square plus 1 raised to power 4. Therefore correct option is B. Question number 44. If x is equal to log of y square, then dy by dx. The options are, let's see which one is the correct option. We are given x is equal to log of y square. We can write it as x is equal to 2 log of y. It can also be written as log of y is equal to x over 2. Now we take derivative on both sides and we get 1 over y into y dash is equal to 1 by 2. This implies y dash will be equal to y over 2. Therefore, the correct option is option D. Question number 45. If y is equal to sine of ax plus b, then yn is equal to. The options are, let's check out which one is the correct option. We are given y is equal to sine of ax plus b. Its first derivative is a into cos of ax plus b. We know that sine of theta plus pi by 2 is equal to cos theta. So this first derivative becomes y dash is equal to a sine of ax plus b plus pi by 2. We have converted the cos into sine using this relation. Now we find the second derivative, which is a square cos of ax plus pi by 2. Now we again convert this cos into sine and we get y double dash is equal to a square sine of ax plus b plus pi by 2 plus pi by 2. Another pi by 2 has been added. So it becomes y double dash is equal to a square sine of ax plus b plus 2 into pi by 2. Note that if we take a second derivative, the power of a is 2 and pi by 2, 2 is multiple of pi by 2. Similarly, we can write y triple dash as a cube sine of ax plus b plus 3 pi by 2. And eventually yn will be equal to, continuing in this way, yn will be equal to a raised to power n sine of ax plus b plus n into pi by 2. Therefore, the correct option is option D. Question 46. The notation used by Leibniz for derivative is, the options are, let's check out which is the correct option, and the correct option is option A. Do remember it. Ding, ding, ding. Question number 47. The series 1 plus x square over 2 factorial plus x4 over 4 factorial plus x6 over 6 factorial is Maclaurin expansion of, and the options are these. Let's check out which one is the correct option, and the correct option is option A. As given series is the Maclaurin series expansion of cos hyperbolic x. So the correct option is option A. Ding, ding, ding. Question number 48. If f of x is equal to secant x, then f dash pi by 2 is. And the options are, let's see which one is the correct option. Here f of x is equal to secant x and its derivative is secant x tangent x. Now we replace x by pi by 2 and get secant pi by 2 into tangent pi by 2. Now the values of secant pi by 2 and tangent pi by 2 are undefined. Therefore, the correct option is option D. Question number 49. Limit x approaches to sin x minus sin 2 over x minus 2 is equal to. And the options are, let's see which of these options is correct option. By definition, f dash a is equal to limit x approaches a, f of x minus f of a over x minus a. Here a is equal to 2, therefore f dash 2 will be equal to limit x approaches to f of x minus f of 2 over x minus 2. Now we see that the function f of x is sine of x and its derivative is f dash x is cos x. F of 2 will be equal to sine of 2 and f dash 2 will be equal to cos of 2. Therefore, this expression becomes cos of 2 is equal to limit x approaches to sine of x minus sine of 2 over x minus 2. Therefore, correct option is cos 2, which is option C. Question number 50. If x is equal to 2t, y is equal to t square, then dy by dx is equal to. And the options are, let's check out which one is the correct option. Here, x is equal to 2t, y is equal to t square. X and y are depending on the variable t. We find dx by dt, which is to dy by dt, which is to t. We apply chain rule and get dy by dx as dy by dx is equal to dy by dt into dt by dx. Dy by dt is equal to 2t and dt by dx is obtained by taking reciprocal of dx by dt, which is 1 over 2. Cancel 2 with 2 and we get t. Therefore, the correct option is option D. Question number 51. The Euler number E is equal to, and the options are, let's see which one of these options is correct. We know that according to Maclaurin series, E of x is equal to 1 plus x square over 2 factorial plus x cube over 3 factorial plus x 4 over 4 factorial and so on. Put x is equal to 1. Therefore, E will be equal to 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial, which will become 1 plus 1 plus 1 over 2, 2 factorial is equal to 2, 3 factorial is equal to 6, 4 factorial is equal to 1 over 24. Therefore, C is the correct option. Question number 52. Two positive real numbers whose sum is 40 and product is maximum or, and the options are, let's see which one is the correct option. We use calculus to solve this multiple choice question. Suppose the numbers are x and y. So x plus y will be equal to 40 and y will be equal to 40 minus x. The product will be x into y. We convert it into only one variable and place value of y, 40 minus x, and product is a 40x minus x square. Its first derivative is 40 minus 2x, second derivative is minus 2. Now we put first derivative is equal to 0. This implies 2x will be equal to 40 and x will be 20. At x is equal to 20, p double dash will remain minus 2, which is less than 0. Since the double derivative is negative, therefore x is equal to 20 is point of maximum value. Now we put this value of x in. Y is equal to 40 minus 20, 20. So 20 is the correct option, which is option C. Question number 53. D by d theta of sine of theta raised to power theta is equal to, and the options are, let's check out which one is the correct option. Place sine theta raised to power theta is equal to y. Here both base and power has variables, so we remove variable theta from the power. For this we take log on both sides and it becomes log of y is equal to theta into log of sine theta. Now we take derivative and we get 1 over y into y dash is equal to log of sine theta into theta dash plus theta into log of sine theta whole derivative. Here we have applied the product rule. Now it becomes, after taking derivative, y dash is equal to y into log of sine theta into 1 plus theta into 1 over sine theta into derivative of sine theta, and it becomes y dash is equal to this. So eventually it becomes sine theta raised to power theta into log of sine theta into 1 plus theta into cotangent theta. Here the value of y has been replaced by sine theta raised to power theta. So the correct option is option B. Question number 54. The particle is at point x at any time t. Find the magnitude of its velocity and acceleration at t is equal to 1. And the options are, let's check out which one is the correct option. We know that the first derivative of displacement is velocity and the second derivative of displacement is acceleration. So dx by dt, which will be the velocity of the particle, will be equal to, we take derivative of given displacement, it becomes 2t into I plus 2j plus 0k, and at t is equal to 1, it becomes, velocity becomes 2 into 1 I plus 2j, and its magnitude is 2 square plus 2 square, and it's a square root, and it becomes a square root of 8, which can be written as 2 into square root of 2. Now we take another derivative of velocity, because acceleration is dv by dt or d2x by dt2. We take the derivative of the velocity and get 2i plus 0j. So the magnitude of A will be equal to 2. So the correct option is option A. Question number 55. The local extrema of this function in the interval 0 to pi is, and the options are, let's find out which one is the correct option. The function is f of x is equal to sine of x plus cos of x. Its first derivative is cos of x minus sine of x. Second derivative is minus sine of x minus cos of x. Now we find the stationary points and put y dash f dash x is equal to 0. So cos of x minus sine of x will be 0, and it gives tan x is equal to 1, and it gives x is equal to pi by 4. Since the interval is 0 to pi, so the quadrants are first and second, and since tangent x is positive, therefore the value of x will be in the first quadrant. So x is equal to pi by 4. Now we put this x is equal to pi by 4 in double derivative, and we get f double dash pi by 4 is equal to minus square root of 2, which is less than 0. That is, double derivative at pi by 4 is less than 0. Therefore, according to second derivative test, the function has local maxima, and the maximum value A will be, if we replace the x is equal to pi by 4 in given function, we get f of pi by 4 is equal to square root of 2. So the correct option is option C. Question number 56. If y is equal to this has a turning point at point 2 minus 1, find the values of a and b respectively. And the options are, let's check out which one is the correct option. If we apply calculus to solve this problem, it will be a lengthy process. Let's use another trick. Here the equation is y is equal to x minus b over x minus 1 x minus 4. Since 2 minus 1 lies on it, so it satisfies this equation, and we get minus 1 is equal to 2a minus b over minus 2. Now what I do, I put the values of given options. First I use option A and put values of a and b as 1 and 0 in this equation, and we get minus 1 is equal to minus 1. So the values a is equal to 1, b is equal to 0 has satisfied our equation, so it will be the correct option. So the correct option is option A. Question number 57. If y is equal to this, then dy by dx at x is equal to 0 will be. And the options are, let's check out which one is the correct option. Here the function is y is equal to this. We convert it into a simpler function and we divide numerator and denominator by cos of x and we get this. We can write it as this. Now I can place this value of y as y is equal to minus tan 45 minus tan x over 1 plus tan 45 tan x, and it can be written as minus tan 45 minus x, and the derivative of this is minus secant square 45 degree minus x into minus 1. So the derivative is this. Now put x is equal to 0 and get secant square 45 degree, which it eventually gives 2. Therefore, the correct option is option C. Question number 58. If x is equal to sine y, then dy by dx. And the options are, let's find out the correct option. Here, x is equal to sine of y. We take derivative on both sides. D by dx of x will be equal to d by dx of sine y, and it will become 1 is equal to cos y into dy by dx. So dy by dx will be equal to 1 over cos y, and that is equal to secant y. Therefore, the correct option is option C. Question number 59. If y is equal to e of 2 log of x, then dy by dx will be equal to, and the options are, let's see which is the correct option. We are given y is equal to e of 2 log of x. We can write it as e of log of x square. Exponential and logarithmic functions will cancel each other and we are left with y is equal to x square. So dy by dx will be equal to 2x. Therefore, B is the correct option. Question number 60. Limit h approaches 0, f of h minus f of 0 over h is equal to. And the options are, let's check out which one is the correct option. By definition of derivative, we know that f dash a is equal to limit h approaches 0, f of a plus h minus f of a over h. Replace a by 0 and we get f dash 0 is equal to limit h approaches 0, f of 0 plus h minus f of 0 over h, and that will become limit h approaches 0, f of h minus f of 0 over h. Therefore, correct option is option C.